There's this idea that comes up in math quite a bit that I don't think people ever stop and think about: ratios. And essentially, a ratio is when you have two numbers being considered together. So, like 2 to 11. And I think a good example of this is, maybe if you can buy two of them for 11. So maybe that's like a nice sale price. Or maybe you need two chaperones for every 11 students on a field trip. So you can see you can't just think about the 11, you can't just think about the 2. You need to think about the 2 and the 11 kind of at the same time going together. And that's what a ratio is. And, Latin, that's where this word ratio comes from. In Latin, it means to understand or measure or consider. And I think a good way of thinking about that is when you measure something, like you have usually a ruler, which is a predetermined measure, and when you have something else and you say, okay, this is 6 feet, you're basically saying it takes 6 of these to equal one of those. And you can see that's pretty similar to this ratio idea, because maybe you could think, okay, if it's 5.5 feet, what that really means is that two of them are 11 feet. So you can see how this measurement and consideration and comparison idea, that's why ratio is the word that describes the math idea of having two numbers together in order to represent a relationship between two quantities. And I think that's maybe why people don't really understand this idea so well, is that it's maybe easier to understand it without words and to understand it through examples. And the more I explain it, the more complicated it gets. Hopefully, I'm not teaching you anything new when I say all of this stuff. I'm just kind of helping you notice things that were already, happening before. Of course, you know that a ratio always has two parts like this, but maybe something you didn't know or didn't recognize is that a rational number, what that is it's a ratio of two whole numbers. And it's written usually like a fraction. So, like 1/4 is 1 out of 4. And then, of course, decimal equivalents of fractions are also rational numbers. And so that's why decimals are rational, because, or at least a lot of decimals are rational, the ones that have fraction equivalents, because they come from fractions, and fractions are ratios, and so of course it makes sense to call them rational numbers. And so, yeah, I think where do rational numbers first come up? You start understanding fractions in third grade. And then in fourth grade, that's when you start doing equivalent fractions. And then also understanding decimals. I'm going to have to move this over here. In fifth grade, that's where you start, rational number operations. Or that's where you really finished rational number operations. So adding, subtracting, multiplying, and dividing with decimals and fractions. And then in sixth grade, that's where you start to get the idea of ratios, things like unit rates, which I'll cover a little bit more of here. You start getting tables. You start getting coordinate planes. And what you can see about all of these ideas here is that they are really two quantities at once. Like, a unit rate is whenever, if I were to reduce this to one of the numbers being a 1, so like that. So that's the unit rate version of this ratio. Now, of course, we could, rather than dividing the ratio, we could multiply it and make an equivalent ratio like this. And if we did a bunch of those ratios together like this, we would make a table. And if we put an x and a y at the top of that table, this starts getting into algebra, and then we could plot those x's and y's on a chart like this. Let's say 11, 22, 33, 44, just to make it easy to graph. 2, 4, 6, 8. And then we see that this is a linear and proportional relationship because it continues the same ratio all the way up the table, all the way up through the graph. And then you can make an equation for this, and maybe this one might be a little bit complicated here, but you could say 11 times x will equal 2 times y, because you need to do 2 times 11 to equal 22, but you need to do over here 2 times 11. And then if you wanted to, write this like a proportion, I guess, you would make this x over 2 equals y over 11. So that looks more like a proportional relationship. But then using algebra rules, you could multiply this 11 over there, so you could turn this into y equals 11 over 2x, which starts to look more like a function. And you see, all of these ideas really just come from this base idea of a ratio, which, what is a ratio again? It's taking two quantities at once. You have rational numbers from it, which are the basis of a lot of 3rd, 4th, and 5th grade math, fractions and decimals. And then starting into 6th, and 7th, and 8th grade math, which is pre-algebra and algebra ideas, you start considering two quantities at once. Either creating a unit rate from it or building a table from repeating that ratio, assuming the proportional relationship continues and creates a pattern. And you can create proportions with that and functions with that, which again is the basis of a lot of middle school and beginning high school math. So hopefully this video was helpful. Hopefully every time you see the word ratio now, your vision is colored a little bit more fluently and a little bit, you understand it a little deeper. And if you learn something from this and like my style, of course visit my website and schedule a session with me. Your first 30-minute session is free. I look forward to helping you out and making math more interesting like this. So thank you for your time and good luck.